We are now going to take a look at a series where required to find the sum. So this particular series is 1 upon 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1 upon n. So n can be the end point or final term in this particular series. I'll just explain one or two things. Each of these block 1 upon 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1 upon 5 is known as one single term. This is one term, this is the second term, third term, fourth term and fifth term. So here what I am required to do is I am required to find the sum of this particular series. So if you look at this particular series, the numerator is constant. The numerator is always 1. The denominator is increasing by 1 every time. So what I can do here is I can again use the repeat for loop to keep track of the denominator. The denominator can be I, okay, and the variable sum, which is initial value 0, can be used to hold the sum of this particular series. Then what else do I require? I require another variable called as n, which tells me what is the last number. Let us say the user enters the last number as 5. So before we go there, let's try to take a look at the logic. First step, as usual, start. In the previous flowchart, in the previous algorithm, I did not show you the initialization of sum. It is a good idea to make the value of the sum memory location to 0 because that is what you will be doing in your program. So what I am saying is initialize sum to 0. I am giving the value sum to 0 because this is going to be 0 plus 1, then 1 plus half, then half plus 1 by 3 plus 1 by 4 plus all the way up till 1 by n. So if you look at this, step 1 is start. Step 2 is give the value of sum to 0 because all these are going to be added to sum. Now what I can do in step 4 is, in step 3 is I need to read the value of n. Let us say I read the value of the last term, this particular n, as 5. So I say input n is 5. Now I need to calculate the sum. That means I need to calculate the sum of all these terms. Okay, I told you one is one term, second term, third term, fourth term and fifth term. I need to find the sum of all these terms. So to calculate the sum, what I can do is I can use the repeat for to see that the denominator starts from 1 and reaches 5. So I starts from 1 and till it reaches 5, I can keep adding 1 upon I to sum. So that is what I have done here. I have taken the value of, this should be not end of while, it should be end of for. Okay, this is end of for loop. All right. So what I'm doing here is take a look here. Repeat for I equal to 1 to n. Sum is 0. 0 plus I is initially 1. 1 upon 1 is sum is 1. I becomes 2. When I becomes 2, then its sum is 1 plus 1 upon 2. 1 plus 1 upon 2 is 1.5. Then I becomes 3. 3 is still not crossed 5. So sum is 1.5 plus 1 upon 3. 1 upon 3 is 0.33. So it becomes 1.85, 833 and so on. So this particular thing keeps repeating till the value of I is from 1 to 5. The minute I becomes 6, it will not execute this. Sum is sum plus 1 upon I. Then you will come out here and you will display the sum. And finally, you will do the end of the algorithm or stop. The best way to understand this is let's run through this logic through certain values. You should always check your logic, drawing a table containing variables and seeing what change happens at each step or during each iteration. That is the only way you will end up knowing whether your logic is right or not. There is no other way to know whether your logic is right or wrong. Start. Initialize sum to 0. Sum is 0. Read the last term. Let us say the value of n I say is 5. Now I come to step number 4. Repeat this step for I equal to 1 to n. I is 1, sum is 0. So I is 1. 1 is still not greater than 5. So sum is 0 plus 1. This is 1. 1 upon I is 1. 1 upon 1 is 1. So sum becomes 1. Now end of for loop, I go here, I becomes 2. So 2 is not crossed 5. So I come here. Sum is 1 plus 1 upon 2 is 0.5. So this becomes 1 plus 0.5 becomes 1.5. Now I go back here. I is increased to 3. I come back here. 1.5 plus 1 upon 3. 1 upon 3 is 0.333. So this becomes 1.833 like this. Okay, 1.833. I becomes 4. All right. So when I becomes 4, I becomes 4 here. So we again come in here. Sum is 1.833 plus 1 upon 4. I is 4. So 1 upon 4 is 0.25 plus this is 0.25. So this becomes, okay, this is crossed now. 3, 5 plus 3, 8, 8 plus 2, 0 carry 1 here. So this has become 2.083. Sum has become 2.083. Now I goes back here, I ends up becoming 5. Sum is 2.083 plus 1 upon 5. 1 upon 5 is equal to 0.20. So 2.083 plus 0.20. This is equal to 8 to 2.2823. So sum now is 2.283. But value of I after this is sum becomes 6. It has crossed from 1 to 5. So I come out here. I display the sum. It is 2.283. I'm not sure this is perfectly right, but the logic is 100% correct. So you just see that I have not missed any addition here. All right. So once you do this, okay, once you do this, you will understand that this is the way you calculate sum of this particular series, and then you find the sum and then you alt.